Hello and welcome to Math 320 video lecture number 2. This time we're going to be going over sections 6.5 through 6.8. This is going to be in preparation for quiz number 1 that's coming up, so definitely get in as much practice as you need to make sure that you're ready for the quiz coming up. But let's jump in. So, of course, get out your workbook, Math 320, and we're going to be going to page 11. And that's when we get to start section 6.5. So for this, we're going to be working on factoring a perfect square trinomial with leading coefficient of 1. So what does that even mean, right? There's a lot of jargon there. Perfect square trinomial leading coefficient 1. Alright, the easiest part is this leading coefficient of 1 part. So what is a coefficient in the first place? Well, anytime you have variables and there's a number in front of those variables, we call these numbers coefficients, right? And so the biggest and baddest of the coefficients is the coefficient that's in front of the biggest power, in this case x squared. And we said that this guy is in charge, he's in the lead. So this is your leading coefficient, would be a 3 in this case, right? If this was a 5, your leading coefficient would be a 5. It doesn't matter what this is or what this is, it's only controlled by the biggest power, right? And it's the number that's in front of that biggest power is your leading coefficient. Now, a lot of times the leading coefficient is just 1, right? But most of the time we're not going to go ahead and write a 1x squared. So when the leading coefficient is 1, you're just going to see the variable by itself. It'll look something like this. So we know that how many x squareds are here? Well, there's 1x squared. So that 1 is what we say is implied. So we know it's there, so therefore we don't write it. If we see an x squared, we know there's exactly one of them. So this is an example of something with a leading coefficient of 1. So perfect, and you notice here just w squared, u squared, right? Leading coefficient of 1. Now, a perfect square trinomial means that this guy here is actually what's known as a perfect square. For example, we know some perfect squares like 9, 16, 25, right? 9 is 3 squared. 16 is 4 squared. 25 is 5 squared. These are perfect squares. But if you think about it, right, that's just numbers. What about variables? Well, x squared is x squared, right? That's also a perfect square because this is just x times x in the same way that 9 is 3 times 3, right? That's a perfect square. Now what happens if things get a little bit more complicated? What if you have something like 5x squared? Well, if you do 5x times 5x, you get 25x squared. Guess what? This is a perfect square. It's 5x times 5x, right? In the same way that 3 times 3 gives you the perfect square of 9. So you can keep getting more and more complicated, and eventually you'll get to what we're looking at right now, which is something like x plus 4 squared. Well, we know that that's just the same thing as x plus 4 times x plus 4, right? And then you do your FOIL first, outer, inner, last, and you'll get that this equals x squared plus the inner is the outer, sorry, is x times 4, so 4x. The inner is 4 times x, so 4x. And the last is 4 times 4, which is 16. Simplify that to x squared plus 8x, 4 plus 4, equals 16. X squared plus 8x plus 16, sorry, not equals 16, plus 16. And it turns out that this is a perfect square. Even though it doesn't look like it, where did this come from? X plus 4 squared. So what they're doing is they're giving us this version and asking us to work backwards to this version. So that's what we're going to be covering here on this factoring a perfect square trinomial. So the good news is we can go about it like we did before, where we try to find the factors of 49 that give us a 14. Right? So we say, okay, well, factors of 49, well, 7 times 7. Right? So we know we're going to have W, and we need a positive 14, so we need a positive 7 and a positive 7. So what are our factors going to be? Well, w plus 7 and w plus 7. Well, w plus 7 plus w times w plus 7 is just w plus 7 squared. Oh, look at that. We found our perfect square. Same deal here. We have a 36. We need to make a negative 12. What are the factors of 36 that give us a negative 12? Well, that would be negative 6 and negative 6. So what's our answer? U minus 6 times u minus 6, which is also known as u minus 6 squared. And just like that, we found a perfect square. So these are the most basic type. And you notice we're using a lot of the same factoring techniques as before. What do you think we're going to do here? Right, we could employ an AC method, but it's going to be a little bit more drawn out than we would want. So instead, we're going to notice that 49 is a perfect square and 4 is a perfect square. And we're going to use our square roots to help us out here. What's the square root of 49? 7. Square root of u squared, u. What's the square root of positive 4 here? Well, that'll be 2, but we notice we need a negative in the middle, so why don't we make that minus 2? And then guess what this is going to be? 7u minus 2 squared. Same deal here. What's the square root of 25v squared? Well, that's 5v. What's the square root of 16? Well, that's 4. What kind of number do we need in the middle? A negative number, and we know it's going to be squared. So the key for these is to look at the first and last terms. If those are both perfect squares, you're probably dealing with a perfect square trinomial. And you could just use a simple pattern like we did here to factor it. So hope that clarifies things. We're going to keep working on the next video, but yeah, good luck with everything. Just make sure you're diligent. This is a very big section, a lot of things that are being covered, so I want to make sure y'all get enough practice. So definitely put the time in to make sure you're comfortable. Until next time, see ya.